大家早上好，我非常荣幸再次呢来到上海第7届区块链全球峰会的来做发言。那么在今年呢，我们也是取得了非常多的进展，在我们的这个互联网计算机方面，我们看到呢，在我们的这个互联网计算机上呢，有成千上万的应用呢正在被部署。对于那些熟悉互联网计算机项目的人来说呢，你们应该知道呢，就是我们的使命呢是建立一个世界级的计算机。那我是 Dominic， 我是 DFINITY 基金会的创始人以及首席科学家。我们在全球范围内邀请了很多的一些密码学的专家以及密码学工程师来加入我们 DFINITY 基金会。那所有的这些人呢，都在帮助我们来建立我们的互联网计算机。那同时呢，我们也在全球范围呢有几家这个研究中心。我们DFINITY 的基金会呢是一个非盈利性的这样的一个组织。那我们的一个目标呢，就是来帮助开发者、企业、个人以及政府来更好的来融入到这个区块链的网络中来。那么，关于区块链的这样的一个独特性，也就是说呢，通过智能合约呢，我们呢可以重新建立这样的一个网络。那刚刚呢，我也讲到了，就是其实呢，我们今年1月份呢才开始创建出来这个互联网计算机，但是呢，在过去的这几个月呢，它已经出现了突飞猛进的进展。我们可以看到呢，我们的这个区块的一个数量呢，已经达到了2亿6900万个。
Data storage. It has more than 20,000 CPUs processing smart contract computations, and the internet computer is self-governed by a thing called the network nervous system, and that thing has processed 26,000 proposals already. So things are really moving. So before we talk about some of the things that the internet computer blockchain can do, let's think for a moment about some of the challenges in today's blockchain space. One of the major challenges is that blockchain architectures are just far too complex. So let's think about how Ethereum dApps work for now, by way of example. So when you interact with an Ethereum dApp, typically you're actually interacting with a website hosted on Amazon Web Services, a cloud infrastructure. That website does most of the heavy-duty computation and data storage and just makes a few calls to the Ethereum blockchain on the back end. In order to interact with the dApp in a meaningful way, you need to have an ETH wallet. Typically, you need to download that from the Chrome Web Store, and it'll work as a Chrome extension that integrates with your web browser. Now, before you can use it, you need to load it with some ETH. Typically, you will acquire that on a cryptocurrency exchange and send it to your wallet, such as MetaMask. Now, when you interact with the dApp, you can go from page to page, but when you actually need to do something that will cause an action on the blockchain, you have to configure a transaction. And that's because you need to pay for the smart contract computation that's going to take place. So all of this presents a number of problems. First of all, the requirement that the user must have some ETH cryptocurrency creates an enormous barrier to entry. Secondly, the need for the user to configure transactions to pay for the computation on Ethereum when they perform certain actions actually creates a lot of friction in the user experience. Lastly, this architecture presents some serious security difficulties. First of all, the user had to trust that nobody at Google had maliciously modified the code of their MetaMask wallet. If that was the case, the malicious changes could result in ETH cryptocurrency being lost. The user doesn't really have any way of knowing that their interactions with the website actually result in actions on the blockchain. They can check it out with a block explorer, but most users aren't technical enough to be able to do with that. The user has to trust that the website running on Amazon Web Services hasn't been hacked and isn't going to do something bad. Lastly, a danger exists that Amazon Web Services will censor the Dapp. And we know that last year during the US election, Amazon Web Services actually closed down a social media service called Parler, and they're very capable of closing down dApps. Okay, so we can see there are some major problems with the way dApps are created today. So the Internet Computer Blockchain is created by an open protocol called ICP, or Internet Computer Protocol. That's where the ICP token gets its name. The ICP protocol is very advanced and uses a lot of completely new cryptography that makes it possible for the internet computer to realize the world computer dream. On the internet computer, smart contract software can be used to build absolutely anything. Web3 dApps, SocialFi, GameFi, DeFi, NFTs, and even traditional websites and enterprise systems. And all without any need to use cloud computing infrastructure such as Amazon Web Services. An interesting aspect of the Internet Computer Blockchain is that it runs entirely from a sovereign physical layer. That means that the node computers that host the Internet Computer Blockchain are dedicated to the task, and no cloud computing infrastructure is involved whatsoever. So the Internet Computer Blockchain hosts dApps and smart contracts on subnet blockchains within the overall network. These subnet blockchains are created by node machines, which are run by independent operator owners. These node machines, of course, are situated within independent data centers around the world. To give you an idea of where we're heading, we believe in 10 years you will see billions of dApps and contracts on the internet computer, thousands of subnet blockchains, and millions of node machines running from thousands of data centers around the world. The internet computer hosts a new breed of advanced smart contracts called canister smart contracts. Canisters are a bundle of WebAssembly bytecode and persistent memory pages. Each canister smart contract is what is known as a software actor. This makes it possible for the internet computer to run vast numbers of canister smart contracts in parallel and to do so in a deterministic way. And that's why it's able to scale out capacity so that it can process any volume of smart contract computation and data required. Today, the internet computer is the only blockchain in the world that is able to host smart contracts using the actor model, and it's absolutely fundamental to the way it approaches the problem of blockchain singularity. Developers can build on the internet computer in a much simpler way. They simply need to upload Canister smart contracts to the internet computer, and that's sufficient to build all manner of highly sophisticated, decentralized systems and services. On the internet computer, Canister smart contracts can serve interactive web content directly to end users without intermediaries. Canister smart contracts also pay for their own computation, which means that end users don't have to hold tokens to pay for computation and can use dApps on the internet computer without first acquiring tokens and putting them into a token wallet. Moreover, users can authenticate themselves to dApps on the internet computer using a system called Internet Identity. Internet Identity enables them to create anonymous user anchors, which they can assign their devices to as a means of authentication. So for example, I've created an Internet Identity anchor to which I've assigned the fingerprint sensor on my MacBook, the Face ID on my phone, and some YubiKeys as a backup. This model means that Web3 apps can run directly from chain, they're more user-friendly, and they provide end-to-end security for the first time. Naturally, in order to fulfill this role, the internet computer has to have incredible speed. By way of example, the internet computer can finalize transactions that update state in about 2 seconds and perform transactions that just query state in just milliseconds. By comparison, Bitcoin takes about 40 minutes to finalize transactions that update state. Ethereum takes about 15 minutes, Cardano takes about 2 minutes, and Solana takes about 16 seconds. And the internet computer is able to achieve this incredible speed with a sovereign physical network and without any use of cloud computing infrastructure. Another important aspect of the internet computer is that the cost of on-chain computation approaches the cost of computation on traditional IT. The reason for this is that the network can scale out its capacity as needed. By contrast, on traditional blockchains, there's only a fixed amount of capacity. This means that traditional blockchains have to auction access to that fixed capacity, and as demand increases, so does the cost of computation. The internet computer works very differently. When the demand for the fixed capacity increases, the internet computer increases the capacity available. And this enables it to prevent people bidding up the cost of computation, keep the cost of computation constant, and keep it low too. So for example, on Ethereum today, the cost of 1 gigabyte of smart contract data can cost you upwards of $250 million. By contrast, on the internet computer blockchain, 1 gigabyte of smart contract data can cost you as little as $5 per year. And this is what makes it possible to build even a social network on the internet computer. Because of the amazing new capabilities of the internet computer blockchain, internet computer developers are pioneering some really important new trends. These include SocialFi, the metaverse, and GameFi. SocialFi blends social media functionality with DeFi functionality. In the future, the users of dApps, and of course SocialFi dApps, are going to become the owners of the dApps and part of the team that runs them. We're also going to see DeFi functionality blending with traditional social media. So in the future, for example, a decentralized chat service might also double as a wallet. That means that you can send cryptocurrency with individual chat messages. It also means that you'll do things like notarize and sign documents using chat messages, or negotiate for NFTs and have atomic transfers take place. SocialFi is going to completely change how we think about both social media and DeFi. Meanwhile, GameFi will transform gaming. On the blockchain, true play to earn becomes possible. Imagine an online multiplayer racing game in which everyone pays into a pot to participate and the winner wins the pot. That kind of thing is the future, and it's going to be absolutely huge. SocialFi and GameFi, of course, are going to blend in to the metaverse, which is already being built out on the internet computer by some very notable creators. In the future, on blockchain, all of these things are going to exist on a continuum, and it's incredibly exciting to see how all this unfolds. Finally, I want to talk about some very exciting developments with the Internet Computer Protocol itself. It's no secret that the Internet Computer Protocol is powered by something called chain key cryptography, which is completely new and was developed by cryptographers working at the DFINITY Foundation. Chain key cryptography is what enables the Internet computer to run so fast and to scale out its capacity. It's also going to enable the integration of the Internet computer network with the Bitcoin network. This means that smart contracts on the Internet computer will gain their own Bitcoin addresses and will be able to send and receive Bitcoin on the Bitcoin blockchain, rather like Ethereum smart contracts have their own Ether address and can send and receive Ether on the Ethereum blockchain. This is extraordinarily exciting and will enable the creation of a new generation of DeFi that runs effectively on Bitcoin. It's also going to provide today $1.5 trillion of liquidity for the Internet computer blockchain. This is probably one of the most incredible developments that have been enabled within blockchain using new cryptography. And I invite everybody to find out more and watch what happens. We think the integration will happen early next year in just over 3 months. So people have also been asking, are we going to use the same technology to integrate with Ethereum? And I'm pleased to tell you that we are. Once we've delivered the Bitcoin integration, we'll move on to Ethereum. That's going to mean that Canister smart contracts on the internet computer are going to be able to call into smart contracts on Ethereum, and smart contracts on Ethereum are going to be able to call back in to internet computer Canister smart contracts. This is going to really enable the Ethereum ecosystem to solve some of the problems that we talked about earlier. So for example, DeFi applications running on Ethereum will be able to use the internet computer to create secure blockchain-based user experiences, and also to store data and perform heavy computations on a blockchain that they want to remove from the Amazon Web Services cloud. So that's incredibly exciting too. Okay, I think that's it from me today. I wish everyone the very best, and hope you enjoy the rest of your conference here. If you want to find out more about the Internet Computer Project, I invite you to go to DFINITY.org or to internetcomputer.org or to smartcontracts.org. Okay, thanks. Bye, everyone.
Thank you, Dominic. Thanks for sharing.